Hello students, let's see another question which came in GATE 2020 Civil Engineering. This was question number 30 in the afternoon session. So the question states that joint IJKLQ, this is the reference figure, IJLQ and M of the frame shown in the figure, which is not drawn to scale, are pin. So these joints IJKLQM are of pin. Continuous member IQ and LJ are connected through a pin at N. So these two are continuous members which are connected at N through pins, and similarly this two. The load acting at the joint I, J and K are along the negative y direction. So the load is acting at I, J and K along the negative y direction, and the load is also acting at the joint L and M. So this is joint L and M, 10 kN each, is acting along the positive x direction, and the distance between these points is given as 1 meter each, and similarly in the vertical direction. So it is asked the magnitude of the horizontal component of reaction in kilonewton at S. So the horizontal component of reaction at the point S is asked. Four options are given: A 5 kN, B 10 kN, C 15 kN. The reference to solve this question can be found out in the lecture Trusses, Method of Section in the course of Mechanics of Solids by Professor M.S. Shivakumar, Department of Civil Engineering, IIT Madras. So to solve this question, first let us consider this joint J. So this is the joint J, and if you would see that this distance is 1 meter and this distance is also 1 meter. So these two angles will be 45 degree each. So this is joint J. This angle would be 45 degree. This angle would be 45 degree. A load of 10 kN is acting at this point. So let the force in NJ member be in this direction, and the member JP in this direction. This is joint J. So let this be X and this be Y. But if you take the horizontal equilibrium reaction at this joint J, so X sine 45 would be equal to Y sine 45. So which implies that X is equal to Y. And if you take the vertical equilibrium of this joint, 10 kN will be equal to X cos 45 two times, because both these forces would be accompanying in the vertical direction. So 10 equal to 2x cos 45 would be 1 by root 2. So X would be equal to, this would be 5 root 2 kilonewton. So this angle would be 45, this angle would be 45. So it will look something like this. Total angle would be 90 degree. Then the forces in these two members, that is NQ and QP, would be 0. That is, they are zero force member, because both of them are connected at 90 degree and no other forces is acting at this joint. So this would be a zero force member. Cutting a section XX through JP and QP, we get the structure like this. This will be one force, this will be the one force, and as we have already calculated, this is 5 root 2 towards the joint, and 10 kN force would be acting like this. There will be 10 kN. This would be joint Q, this would be joint S, there would be the joint M, and this will be the joint P, and this will be a zero force member. So considering the horizontal equilibrium at this joint, so 5 root 2 cos 45 plus 10 would be equal to reaction at S, horizontal reaction at S, which will be equal to 5 plus 10 equal to 15. That is 15 kilonewton. So correct answer would be 15 kilonewton, which is option number C. Thank you.